Okay, so today's talk is going to be a little bit about exception handling, and maybe somewhere along the way in your experience with computers, you've run into an unhandled exception, and they can be really no fun to deal with if you run into them out there in the wild. So, what do you do as a C++ programmer to avoid having unhandled exceptions? So, Malik, the author of our textbook, says an exception is an occurrence of an undesirable situation that can be detected during program execution. You can always ignore exceptions, and that'll end up with a terminated program. But a lot of times you don't have that option. You'll have a undesirable situation, and you have to do something to get out of it. For example, a satellite navigation program. You don't want the satellite to crash, or a medical device such as an insulin pump. You don't want the insulin pump to go out and not allow people to receive their insulin if they're in a hospital situation. So one thing you can do is you can assert, and the assert function basically is used to check if an expression meets certain criteria. If these conditions are not met, it terminates the program. So, if I were doing a division, I can assert the divisor is not equal to 0. Basically, I'm convinced that somebody has provided me with a non-zero input. I'm not doing division by 0. And assuming that the divisor is not 0, then the program will continue. If the divisor for some reason is 0, the program will terminate. So exception handling allows us to add code that occurs at the point where the error can occur, and it provides a way to deal with things when something goes wrong. If you don't deal with it, then it gets passed up from the runtime environment of the language all the way up to the operating system. And if the operating system has no way to deal with it, you get this kind of nice blue screen of death, although Windows has more and more exception handling and does a better job of dealing with rogue exceptions. So, we don't see that one as much anymore, but it used to be very, very common. So, first toy example is we'd like to know how many donuts we can get per glass of milk. Well, it's pretty easy to take the number of donuts we have, say, 6 donuts and 1 glass of milk, then we have 6 donuts per glass of milk. Or if we have 2 glasses of milk, we have 3 donuts per glass of milk. But that can be a problem when we're out of milk. And one way to deal with this issue is to use an if-then-else statement. You can say, if milk equals 0, say, oh my gosh, we're out of milk. Otherwise, perform the calculation donut per gallon equals donuts divided by milk. You can actually do the same thing with exception handling. And here you have a try, throw, catch structure. So try is basically the usual situation. So we're going to try to enter the number of donuts, number of glasses of milk, and determine the donuts per glass of milk. If milk is less than or equal to 0, then what we do is we throw donuts. So this provides additional information to the exception handler. So here is the throwing of the exception, where we throw the donuts, and then there's a catch, which is an exception handler, and it takes a parameter of type integer. And they'll say, hey, you've got so many donuts and no milk, go buy some milk. So it gives us some additional information. So try deals with the normal situation. We're not 100% sure, but we're going to give it the old college try. When you throw an exception, it means something went wrong, and the value thrown is the exception. Catch block deals with the exceptional circumstances. It looks like a function, and it's also called an exception handler. So that int e is known as the catch block parameter, and it does 3 things. It specifies the type of exception that can be caught. The thrown type needs to match the catch type, and it gives a name to the thrown value, so you can use it to provide additional information or to even, perhaps rectify the exception. And then it contains an exception handler. So how is this different from if-then-else? Well, yes, it's pretty similar, but try, throw, catch can send a message to one of its blocks. It also transfers that flow of control immediately. And once an exception is thrown, we ignore everything else in the try block. So it's a little bit structurally different. If you don't throw an exception, the catch block gets ignored. So you don't deal with the catch block. You can also write classes to handle exceptions, and these can provide even more information. So imagine we have our donuts per glass of milk example, and we have a class called no milk. It has a constructor that says how many donuts we have, and a accessor function to get the donuts. The private information or the attributes for it are the count, and that tells how many donuts there are. And then basically we can use this like any other value that we throw, and we can throw no milk and send it the donuts as a constructor, and that gives us the additional information. An exception class could be more complicated, and there could be more information that would help somebody debug that in a runtime environment. You can have different types of exceptions in a try block, and so you could have one that throws int, one that throws double, one that throws out of memory or Batalex, but only one type of exception gets caught by any particular exception handler. So you can also have multiple catches. The order is important. So you want to put the most specific one first and then put the most general one last, because the program will go with the first one that matches. There is also a catchall, and that's the ellipsis. Basically, it'll catch anything. So this one is the one that you put last, because you don't want to catch the most general exception. You want to get as specific information as possible in order to debug it. You can also have trivial exception classes such as divide by zero. You can also throw exception from a function. So if you're using a function, you can throw an exception, and basically, it might be that, hey, the program should end, otherwise some might want to do something else. So you need to make sure that the function knows how to handle the exception. So if you basically throw an exception but don't catch it, it goes back to main to catch the exception. And then if there's nothing in main, it's going to terminate the program and forward that onto the operating system. And hopefully the operating system has something to catch it. If a function doesn't catch an exception, it should warn programmers that an exception might be thrown by the function. So here we write a function double safe divide, and then we throw divide by zero. So if multiple ones are thrown, divide by zero and other exceptions, we should list them all, just so that people know that, hey, this is going to, possibly throw an exception. And if you're the application programmer using this in your main program, be prepared to possibly deal with this exception. If you throw an exception, you need to catch it somewhere. If not, your program's going to end probably abnormally. Avoid using nested try catch blocks. Sometimes this can be hard if you have a lot of exception handling, but and you can do it, of course, because it's C++, but it makes it, the term was spaghetti code, where it was impossible to trace what was going on. Don't overuse exceptions. It makes for a lot of flow of control, and it's in some ways equivalent to the old go-to statement that Dijkstra warned back in the 60s was to be considered dangerous. So when do you use it? To process synchronous errors, for example, non-events. Some common examples are out-of-range array subscripts, like say I have an array that goes from 0 to 100, and I give it a value of 101. I should probably, get an out-of-range array subscript and basically have an exception to deal with that. Arithmetic overflow, if it goes beyond the bounds of, what can be handled within a double or a float, then I need an arithmetic overflow exception handler. Division by zero, of course, which we've talked about. Invalid function parameters and unsuccessful memory allocation. C++ does have exception classes, and it provides support to handle exceptions via hierarchy of classes. The class exception is the base class, and then you have the subclasses. It also has a function what, and it's contained in the class exception, and what returns a string containing an appropriate error message. We'll go over an example with what. Two subclasses of exception: logic error, which includes subclasses for invalid argument, out of range, and length error. And that's if a length is greater than the maximum allowed for a string object. You try to read in War and Peace and put in one string. Most systems, that's going to throw an exception. and overflow and underflow error. So here's an example using what. So basically, here we have two strings. We have line 11 sentence is equal to the sentence, line 12 sentence length, and so the sentence is testing string exceptions. And then string 1 is equal to substring from 8 and take 20 characters, and that should be okay. This one starts at 28 and takes 10 characters, and that's going to give you out of range because this is longer than 28 and certainly not going all the way up to 38 characters. And basically what happens there is we throw an out of range error, and the out of range error is denoted by RE as the catch block parameter, and then we can do what, and it'll say invalid string position. So again, it can help us with debugging, or what's going wrong with a program. And one final trick, if you want to see if you have available memory from the free store before allocating it, you can use Batalex. So in this code here, I'm trying to get a list, and I'm trying to make that list of 500 million. That's probably going to be a bit long. In which case I need to, I'm probably going to get an exception, which is going to be a bad alloc, and basically it's say ran out of memory, go get more memory in the same way that we would get more milk, or, you can always download more memory. So that's a very short lecture for today. Remember to work on your programs and labs.